Hi everyone, myself Nithin Heraje, Assistant Professor, Department of Computer Science and Engineering, AJ Institute of Engineering and Technology, Mangaluru. The next uh, in this video, I'm going to discuss about channelization. In my previous videos, I discussed about a random access protocol, after which we discussed about controlled access protocol, and now I'm going to discuss about channelization protocols. So under channelization, we have three different techniques or methods, that is frequency division multiple access, which is called as FDMA. Second one is time division multiple access, which is called as TDMA. And third one is code division multiple access, which is called as CDMA. Okay, so let's see what is channelization. Channelization is a multiple access method in which the available bandwidth of a link is shared in time, frequency, or code. Okay, between different stations. So the bandwidth is shared here. It might be based on time or frequency or code between the stations. Okay, this is how channelization is going to work. So under that we'll see what is frequency division multiple access, then with the TDMA, and then finally with CDMA. Okay, so let's see what is FDMA. In frequency division multiple access, that is FDMA, the available bandwidth is divided into frequency bands. So here whatever the bandwidth is available in the channel, that is divided into frequency bands, and these bands, frequency bands, will be divided with the number of stations that are there. Each station is allocated to a band to send its data. So each station will have its own band to send the data. Each band is reserved for a specific station, and it belongs to the station all the time, so that the station can send the data at any time through its reserved band. It does not have to sense the channel, or it does not have to wait for the permission. It has its own reserved band, so anytime the station can send the data. Each station also uses a band pass filter to confine the transmitter frequencies. So it uses a band pass filter to know what is its band. Okay, what is its transmitter frequency. All right. To prevent station interference, the allocated bands are separated from one another by a small guard band. So here guard bands are used. It's as good as like a compound wall between the bands of different stations. Okay, so uh, this guard band is there just to avoid the interference between the stations. All right. Let's look at this diagram over here. You have four stations here: station 1, 2, 3, 4. Okay, and if you look at this channel, in this channel the frequency is divided into four bands. You can see the different colors over here, and then between every band you can see a layer which is called as the guard band, just to avoid the interference between the bands. Okay, so if you look at station 1 is allocated with this blue color band. Okay, and this is the frequency range for station 1. which is identified by the filter to transmit the data. For station 2, this is the frequency range with the yellow color, okay, where it can send data at any time at this particular band. For station 3, this green color is the band that has been reserved. So at any point of time, it can send the data. And station 4, it has this band, okay, where the frequency is here. So this is the range of the frequency for station 4 to send the data. If you look at this, station 1, 2 and 4 has data to send, where station 3 has no data to send. Though any station does not have any data to send, it does not matter, because each station is given with its own bands, frequency bands, to transfer the data. So simultaneously it can transfer the data without any uh, interference between the data. So it is as good as in the real life you tune to radio frequencies, right, to have a particular channel. For example, you have 98.3, which is one channel, and 92.7 is another channel. So that 92.7 is the band frequency given for one particular channel, and 98.3 is one frequency band given for another channel. Okay, so this is how frequency division multiple access is going to work. All right, so here you have already seen that any station can send data at any point of time through its reserved frequency band. All right. So in FDMA, that is frequency division multiple access, the available bandwidth of the common channel is divided into bands that are separated by guard bands. Okay. Next is that time division multiple access, that is TDMA. So this is almost similar to that of FDMA, where in FDMA the frequency was divided, you had no relation with the time, where in TDMA the time slots are divided and it does not have anything to deal with the frequency. So let's see what it is. In time division multiple access, that is TDMA, the stations share the bandwidth of the channel. Each station is allocated a time slot during which it can send the data. Each station transmits its data in its assigned time slot. So if you look at this diagram for station 1, so this particular thing with the blue color is the time slot given to send its data, and for station 2 this particular thing with the yellow color is given the time slot to send the data. Station 3 is this green one to send the data, but then station 3 does not have any data to send, but that does not matter. The time slot will be given to all the stations irrespective that particular station has to send the data or not. And for station 4, this pink color is the time slot given to send the data. Okay, this is a common channel where time is divided into different slots to send the data. All right, so this is how TDMA is going to work, which is almost similar to that of FDMA. So in TDMA, the bandwidth is just one channel, that is time shared between different stations. So you have one single bandwidth in just one channel, but the time has been shared between different stations. Okay, so we'll proceed to the next one, that is CDMA, that is code division multiple access. In code division multiple access, one channel carries all transmissions simultaneously. So here there is no division that one station will send at a time. Correct? If we went through the previous one, there were in the frequency, all station could send simultaneously, but there was a frequency restriction. There was a frequency band set to each station. Next, we had a look through the time division multiple access, where time slots been given for one particular station. But here in CDMA, one channel will carry all transmissions simultaneously. Alright, so all stations can send data at once. So how it happens, we'll just look at here. These are the different channels, the station 1 different stations. So that is station 1, 2, 3 and 4. So station 1 has a data 1 to send, station 2 has data 2 to send, 3 has data 3 to send, 4 has data 4 to send. And along with that, each station is given with the code. Okay, so station 1 is given with the code C1, station 2 is given with the code C2, station 4 is given with the code C4, and the 3 is given with the code C3. You can see that it is a dot product, so it is multiplied with the data is multiplied with the code. Okay, and then it is transmitted with the channel, and in the channel, if you see, all the data and the code sent from different stations is summed up. Okay, so this is that whole data that is transmitted in the common channel. Okay, so simultaneously all the stations can send its data without any issue. All right. So we'll see the chip sequences. CDMA is based on coding theory. Each station is assigned a code which is a sequence of numbers called chips. So these are the chips that we are going to have. If you see C1, which was given for station 1, there is +1, +1, +1, +1. For station 2, we have +1, -1, +1, -1. For station 3, the code 3 is +1, +1, -1, -1. For station 4, the code 4 is +1, -1, -1, +1. Okay, so codes are called orthogonal sequences and have the following properties. We'll see what are those properties. So each sequence is made of n elements. You can see there n elements, 1, 2, 3 and 4. So n elements are there, where n is the number of stations. So if we have 4 stations, this code chip will have 4 elements. If there are totally 6 stations, then this code chips will have 6 elements in it. Alright, so that's what that first point means. Second, if we multiply a sequence by a number, say for example here they have taken it as 2, every element in the sequence is multiplied by that element. So 2 is multiplied with these elements. Okay, so the result will be this +2, +2, -2, -2. That is, these elements, all the elements are multiplied by this value. Okay, the third point is that if we multiply two equal sequences, element by element, and add the results, we get n. N is the number of stations. So you look at this, you have +1, +1, -1, -1, multiplied with +1, +1, -1, -1. That means if this is +1, +1, -1 is nothing but code 3. So code 3 is multiplied with the code 3, then we will get the 4 as the result. 4 is nothing but n, that is number of stations. Okay, so same code is multiplied, then you get n as the value. Okay, that is property 3. The fourth property is that if we multiply two different sequences, element by element, and add the result, we get 0. So you have plus 1 plus 1 minus 1 minus 1, here plus 1 plus 1 plus 1 plus 1. So two different sequences. It might be this might be code 1, this might be code 3. Okay, so code 3 is multiplied with code 1, and final result you get it as 0. That is if two different sequences. That means two different codes are multiplied, then the value is 0. Alright. Next, fifth property is that adding two sequences means adding the corresponding elements. The result is another sequence. That is, if you add this one code sequence with another code sequence, this is the result. So how to do this is, this element should be added with the first element over here. So plus 1 you get it as plus 2. Plus 1, second element over here, plus 1, you get it plus 2. Third element minus 1, third element plus 1, you get it as 0. Fourth element minus 1 and fourth element plus 1, you get it as 0. Okay, so we have used plus 1, minus 1 and 0. So these three bits have different meaning. If it is minus 1, the data bit is 0. So if it is plus 1, the data bit will be set as 1. And if it is silence, it is 0. Okay, so these are the three meanings. If it is 0, the station is silent, it does not have anything to send. If the data bit is 1, then it is plus 1. If the data bit is 0, it is minus 1. Okay, just look at this diagram. Here it is a bit 0, right? Bit 0 means that is minus 1 is the data to be sent. Bit 0, then minus 1 data to be sent. If it is bit 1, it is plus 1 data to be sent. And if it is silent, then 0 is being sent. Okay, so you can look at this here, data into the code. You get it as minus 1, minus 1, minus 1, minus 1, because this data, that is minus 1, is multiplied with the code over here. Similarly, this minus 1 is multiplied with the code over here, and you get the result as minus 1 plus 1 minus 1 plus 1. Similarly, here also this code is multiplied with the plus 1, so you get it this, that is D4 into C4. Here it is D3 into C3, that is 0 into this, remains everything as 0. Okay, and finally in the channel you are going to get minus 1, minus 1, minus 3 and plus 1. Okay, this is the data that been transferred in this. Okay, how did you get this? That you will have to sum up, that is D1 C1 plus D2 C2 plus D3 C3 plus D4 C4. So how you do the addition? You do the addition by using this second, sorry, not second one. Okay, so this by using the fifth property, that is adding two sequences, which means adding the corresponding elements. It is two or more sequences you are going to add, and finally this is that data you are going to get. Okay, so this is one way, and other way here to solve is that you can also solve this way, that is data equal to D1 C1 plus D2 C2 plus D3 C3 plus D4 C4 into C1. If this is into C1, that means you are going to multiply everything here, that is D1 C1 C1 plus D2 C2 C1 plus D3 C3 C1 plus D4, C4, C1. And we know that we have again two properties. So we have multiplied this by using the property number here 2, that is, you just multiply with the whatever value you are going to have. Okay, next we have is that two property 3. If the codes are the same codes are multiplied, then you will get n. And property 4, if two different codes are multiplied, then you are going to get the value as 0. Okay, so look at this. Here two codes being multiplied, so you will get the value as n, that is n is 4 and d1 is as it is. And here if you look at this, two different codes, so the value is 0, so 0 into 0 is 0. Here also two different codes are 0, 0 into anything, that is d3, it is 0. Here C4 into C1 is 0, so d4 into d4 is also 0. So all all these three terms you get it as 0. And here you get C1 into C1 as n value is number of stations, that is 4, and d1 remains as it is, so the value will be 4 into d1. So this is how you need to solve by applying those 5 properties. Okay, I hope you understood this, right? Next one is here. So digital signal created by 4 stations in CDMA. We'll see how these 4 stations are created. So you have these sequences over here, right? And we need to sum up this. So this represents all -1, all lower to the frequency. So this is -1 plus 1 -1 plus 1. This is 0 plus 1 -1 -1 plus 1, and this is the data on the channel. How do we get the data on the channel? You look at this. -1 -1, it is -2 plus 1, -2 plus 1, it is -1. So you have this slot as -1. Coming to the second one, second element, you have -1 plus 1, which is 0. 0 plus 0 is 0. And you have here it is -1. So you get it again the second slot as -1. Go to the third slot, you have -1 here, -1 here, which gives you -2. -2 plus 0 is -2. -2 minus 1, it is -3. So we have 3 negatives here. Okay, so this is -3. And here we have -1 plus 1 is 0 plus 1, again you get it as plus 1. Okay, so this is that data we got it, -1 -1 -3 and plus 1, that data to be transferred in the channel. Alright, I hope you understood how we got this. And lastly we have this creating the Walsh tables. So general rule and examples for creating the Walsh tables, we have it here. Okay, so to generate a chip sequences, we use a Walsh table, which is a 2-dimensional table with an equal number of rows and columns. Okay, so we have this W1 as +1, and W2n is, this is what you have to follow. W2n is nothing but Wn, 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 all are positive, and the last one is negative, that is the transpose of the element. So if it is a +1, then it should be -1. Okay, so these are the two basic rules over here. Okay, next we'll see how to generate this. We have W1 as +1, W2 as +1, +1, +1 and -1. Since it is +1, here we have +1, +1, +1 and -1. Now what is W4? W4, we have this whole thing as +1, this whole thing as +1, this whole thing as +1, and this whole thing as -1. And if you apply that -1 of -1, you will get it as +1 over here. Okay, first let us come to this W4 is nothing but here W2 into N, where N is also 2. So first let us take care of this 4 blocks where you have this Wn, Wn, Wn and minus 1. So you have plus 1, plus 1, plus 1 and minus 1. Next here also the same thing, plus 1, plus 1, plus 1 and minus 1. And here also same thing, plus 1, plus 1, plus 1 and minus 1. When coming to this is already a negative value, right? So since we have a negative here, correct? So this plus 1 becomes minus 1, this plus 1 becomes minus 1 because of this. This plus 1 becomes minus 1 because of this. And this should be a minus 1, but the minus of minus becomes plus 1. Okay, so this is how you create a Warshaw's table. Next you have again W2 of N, that is nothing but W8. You can have W8, okay, where you have 8 cross 8 elements over there. Okay, so that is the next example you can try. Alright, the number of sequences in a Walsh table needs to be n equal to 2 power m. So n should be always 2 power m. So this is the point to remember. So I hope you are clear with the last protocol, channelization protocols. Okay, so I hope you are clear with this. Alright, I hope you understood this also. Okay. Thanks for watching this video. If you like, please click on the like button. Thank you so much. Thanks for watching.